Okay, I'm going to talk about local minimum, local maximum. So in the derivative, assume we have an equation. For example, f is equal to, let's say, x squared plus 5. When we draw a graph like this, how will it look? F of x is x squared plus 5 will be like this. Well, we know that this function will only give a local, will give a, well, even. It's not just a local, it's a global minimum in here. But how can we find out where is the minimum and whether it is a minimum or maximum? So what are we going to do? We are going to derivative the f of x with respect to dx. What will we get? We will get, that will be 2x. Okay, well, but why will it be useful to know about this information? Think about this. This slope in here is 0. That is the turning point. That is the turning point from this, which is a negative slope, to a positive slope. That is 0. So when we know this derivative equals 0, then we know if we set this is equal to 0, then we know where is x. Where is this x? To have the local, I should say, to have the turning point happen. Okay, we want to set this to be 0 because we want to set this equation, slope equation. This part is the slope equation. So this is the slope, that 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 is the slope. This is the slope equation is equal to 0 because that is a turning point. Turning point. But from here, from this equation, even we set that is equal to 0, we solve it, x would be equal to 0. It doesn't tell us whether it is a minimum or maximum. How can we do that? So the way we do it is we are going to differentiate this twice. So after we differentiate the first time, that is 2x. If we differentiate one more time, what will happen? Let me clean up this area. Okay, we know this. If we differentiate one more time, that would be equal to 2. But what that means? What that means is this. We can draw this in here. F prime of x. We know at this point in here, still 0. We can roughly draw this. Okay, we know this part, negative part, is negative. This negative x part, the slope is negative. And the slope is increase. The value of the slope is increasing. So that is something like this. Okay, we should be passing the 0 point in here. Okay, so the question is, why are we going to differentiate one more time? We know we need to differentiate one more time in order to get number and in order to get something. So why are we going to differentiate one more time? Think about this. The slope in here is a positive slope, positive slope, positive slope, positive slope, positive slope. What that means is this: even though let's think about that is like velocity, acceleration, and position. This green line is velocity. This yellow line in here is acceleration. So, even though the velocity could be negative in here, the slope of it, the tangent line of it is positive at every single point. That means that is accelerating. That means is you go, let's say you start from a wrong direction, you moving in a wrong direction, but you are now changing your direction and accelerate in a positive, correct direction. Then you will still moving up. The velocity will move up and the position will move up. In other words, that means you will have a turning point from a wrong direction go to a correct direction. You will have your lowest point somehow. So when this differentiate f of x trace, if it is equal to a positive number, that means your curve f of x in here have a local minimum at that specific turning point. That's why it is a local minimum, because it is the slope of the velocity. I'm talking about is the slope of the velocity, which is the acceleration, is always be positive. When you think about the acceleration, it's always be positive value. Then that means even though the velocity originally is negative, but it keeps accelerating, it will go to positive at some times. At that specific turning point, when you put in this specific value, because f of x, when f is f differentiate trace, put 0 in there, is still equal to 2 because it is positive. It will move up at the end. So that's why differentiate trace get a positive number when we put x at that turning point. After we find the turning point, we put into x. If you get a positive number, that means we get a local minimum.